Good morning, everyone. Good morning, all of you. Welcome to Sanvi E-Learning Services School at your fingertips. How are you, children? Hope you are well. Today we are going to discuss the last topic, metals and non-metallic properties. Metals and non-metals properties in the periodic table. Physical Science Class 10, Lesson 7, classification of elements, the periodic table. Aim. Do you know about the modern periodic table? Agenda. Ionization energy already completed. We have learned the electron affinity also completed. Next, electronegativity, metallic and non-metallic properties. Keywords. Ionization, atomic radius, penetration, orbital, potential. Divya, unmute yourself, Amma.
Good morning, madam.
Very good morning. Can you read the keywords?
Ionization, atomic radius, penetration, orbitals, potential.
Yes, sir. Very good. Electron affinity, already yesterday we have discussed it. The electron affinity for releasing the when an electron is added to the outermost shell is known as a electron affinity. Can anyone say what is ionization? Ionization energy. Both are different. Yes, both are different. Ionization and electron affinity. Electron affinity. Can anyone say what is the difference between these two? Both also depending on electron only. Adding or removing electrons. Adding or removing electrons from the outermost shell or orbitals. Can anyone say what is the difference between ionization? Yes, very good. Amina.
Good morning, ma'am.
Very good morning, Amma.
Ma'am, ionization energy means that energy which is required to remove an electron from an atom.
Yes, very good.
And electron affinity, it means the energy which is released when we add an electron to an atom.
Yeah, very good, very good. So that variation you have to know, Amma. Okay, that variation you have to know. Removing and adding the electron. Removing or adding the electron to the outermost shell or orbital. Okay. So in the ionization energy is nothing but the energy required to remove an electron from the outermost shell or orbital is known as ionization energy. Electron affinity is nothing but it is adding in the electron from the adding to the electron from the to the outermost shell. Okay. The both also it is isolated gaseous. Okay. Coming to the Electronegativity. Electronegativity. Electronegativity is the chemical compounds. The chemical compounds, for example, NaCl or HCl, these are the chemical compounds. For these chemical compounds, we have to, how individually, if we think in HCl, H is a hydrogen, Cl is a chlorine. Individually, H is a hydrogen, Cl is a chlorine. Okay. But when it is a loss of electron or a gain of electron is a atom. Sorry, loss of or gain of electrons are attract to the elements. Sorry, attract to the electrons. Attract to the electrons. So when one electron is take from the hydrogen, the chlorine, when one electron is take from the hydrogen, then we will get the one compound, that is a chemical compound HCl. Individually, it is a outer shell electrons are hydrogen is a 1 and the chlorine is a 1. So that one electron, chlorine, it will take from the hydrogen. So we will get the compound, chemical compound is a hydrochloric acid. Hydrochloric acid. Individually, it is a, these are the elements. These are the elements. Okay. So hydrogen and chlorine. Hydrogen and chlorine. Okay. So that's why here the chemical compound, I'm taking the example is HCl, individually H plus and Cl minus. The when H plus means only one electron. One electron is a loss of electron. This one electron it will take from the chlorine, it will take from the hydrogen. Then we will get the form that is a HCl, hydrochloric acid. Okay. This electron negativity, it is increasing across the periods. It is increasing across the periods. Why it will increase across the periods? From left to right, the outermost electrons are decreasing. That's why the increasing electronegativity. Increasing electronegativity. Okay. And in the periods it will decrease. Shells are same. So that's why it is decreasing in the groups. It is decreasing in the groups. Okay. And bonding atoms also it is a nucleus. Bonding atoms also it is a nucleus. So that's why it is increasing in the period from left to right and decreasing in the groups from top to bottom. Top to bottom. Electronegativity is depending on a ionization energy plus electroaffinity by 2. Ionization energy plus electroaffinity by 2. Electroaffinity by 2. Okay. So electronegativity is depending on ionization energy and electron affinity. Ionization energy and electron affinity. Okay. So this is the formula. This is according to the Millikan. This according to the scientist name is a Millikan. He proposed that electronegativity is depending on ionization energy plus electron affinity. Electron affinity. Okay, that's why the formula of electronegativity is equal to ionization energy plus electron affinity by 2. Ionization energy plus electron affinity by 2. Next, metallic nature. Metallic nature. Here in the periods groups, let me show. Yes, this is a periodic table. In the periodic table, third D block elements all are metals. D block elements are metals. D block elements are metals. These D block elements, 3rd to 12th, these all are metals. These all are metals. Okay. These all are metals. Remaining are metalloids, non-metals, gaseous forms are there. 18th group total it is noble gases. Noble gases. Okay. Now coming to here. Here you see. These aluminium, germanium, scandium, gallium, these all are arsenic. These all actually metalloids. Metalloids. These are non-metals. These are non-metals. These are metalloids. These are salts. 17th groups are salts. Fluorine, chlorine, bromine, iodine. Okay, these are salts. See here, D block elements all are metals. D block elements all are metals. 18th group elements are noble gaseous. Noble gaseous. And 17th group salts. 17th group salts. And 16th group, here carbon, nitrogen, oxygen, phosphorus, sulfur, these all elements non-metals. 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 And these all are boron, silicon, germanium, arsenic. These all are metalloids. Metalloids. These all are metalloids. Okay, it is not a metal properties, not a, it is a intermediate. Some properties are metals and some properties are non-metals properties to the elements of boron, silicon, germanium, arsenic. Okay. So this is a periodic table. In the periodic table, we are learning about the D block elements, metallic nature. Yes. Metallic nature. Actually, the metals are the electropositive elements. Electropositive elements. Can anyone say one example of metal? Anyone? Metal example. So I am taking copper, for example. Why? Because it is a good conductor. That's why I am taking here copper. Now I am taking here copper. Can anyone say what is the atomic number of copper? Here, Tunduri. Unmute yourself, Amma. Adarsh, yes. Adarsh, can you say what is the atomic number of copper? Can you say? Can anyone say what is the atomic number of copper? Sharanya.
Good morning, madam.
Very good morning, Amma.
Madam, atomic number of copper is 29.
29. Can you say the electron configuration?
Yes, madam.
Okay, tell.
1s2, 2s2, 2p6, 3s2,
Yes.
3p6,
Very good.
4s2. Sorry, madam.
Very good.
4s1. 4s1, madam.
Yeah. Okay.
3d10.
4s1, 3d10.
3d10.
Yes. Before actually, what is the commonly? 4s2, 3d9. Is it or not? 4s2. Very good. 4s2, 3d9. Okay. Outer shell electrons, how many? Valency. Okay. Valency electron is a 1. Okay. Why? Because that d orbital, it will occupy only 10 electrons. D orbital, it will occupy only 10 electrons. So how many are there here? 9 electrons are there. Okay. If it will take one electron, so it is become a stable. So that's why this one electron, it will take from the s orbital. From this. Okay. Now the electron configuration is a 4s1 and a 3d10. So it is the metals or electropositive elements. The metals or electropositive elements. It is shows less electronegativity. Less electronegativity character. The metals, it can show the less electronegativity. Only metals. I am telling about the only metals character. Only metal characters. Actually, the metals are very. It is in the d orbitals is known as in the periodic table. D orbitals is known as D block elements is known as metals. These metals are electropositive elements, and it shows the less electronegativity character. So that's why in the groups, top to bottom is increasing. And in the periods, left to right is decreasing. This is about the metals. Not only copper, chromium also. Actually the outer shell electrons are only 4s2, 3d4. So the orbitals, fulfilled or off-filled electrons are present in that. Then it is become a try to get the stable. So that's why the outer shell electronic configuration chromium is a 24. Atomic number is 24. Directly I am writing 4s2 3d4. Okay. So when it will take one electron from the s orbital. So 4s1 3d5. This is the electronic configuration of chromium. Now coming to the non-metals character. The non-metals actually, these are electronegativity. The non-metals are more electronegativity. Less electronegativity is in the metals. More electronegativity is in the non-metals. So due to the smaller atomic radius, in the groups actually top to bottom is decreasing. In the non-metals, or the more electronegativity due to their smaller atomic radius. So in the groups, top to bottom is decreasing. In the periods, left to right is increasing. In the periods, left to right is increasing. The groups left to right is increasing. Now this is your activity. This is your homework, Amma. Periodic properties of elements and their trends in groups and in periods. This is a very, very important, Amma. Valency. Can anyone say what is valency? Valency, yes. Always Amina, she is raising hand. Very good. Amina.
Good morning, ma'am.
Very good morning.
Combining power of an element with another element is valency.
Very good, very good. Combining power of an element on elements to the any other elements is known as a valency. Valency. Next, the valency is a groups and in the periods how it will change once you see, Amma. The same for all elements. Same for all elements in the groups, top to bottom. The top to bottom, same for all elements. In the periods, increase from the 1 to 4 and decreases to all. Okay, decreases to the all to the 0. Why it is a decreases? Why? Because the periods last group is last group elements are fulfilled. Outer shell electrons always fulfilled. So valency always 0. 18th group. So in the periods, that's why increasing from 1 to 4 and it decreases to the 0. Why? Because it is a 0 group elements. Last. Can anyone say what is atomic radius? Yes, sir. Divyashree.
The distance from nucleus to outermost shell of an atom is called as atomic radius.
Very good. The distance between nucleus to the outermost orbital is known as a
Atomic radius.
atomic radius. Yes, very good. This atomic radius is in the groups. In the groups, actually, it is increasing. Top to bottom is increasing. Why it is increasing? The shells are in the groups. Shells are increasing. 1 years, 2 years, 3 years, 4 years, like that. In the groups, shells are increasing. That's why top to bottom is increasing. In the periods, decreasing. Why? Because it is a fixed. Sorry, valency is decreasing. Valency is decreasing in the outermost orbits. So that's why in the periods is decreasing. Next, ionization energy. Ionization energy. What is ionization energy? Yes, Abhilasha.
Madam, the energy required to remove an electron from an atom is known as ionization energy.
Yes, the energy required to remove an atom from the outermost electron is known as ionization energy. This ionization energy also, it is decreasing in the groups from top to bottom. top to bottom, it is a decreasing. Why? Because we are taking one electron, removing the one electron. I told you, removing also for adding also, it need energy. It need energy. Okay. So in the groups, it is a top to bottom, it is a decreasing. Ionization is a decreasing. In the periods, it is a increasing. Periods, it is a increasing. Why? Because the outer shell electrons are decreasing. So that's why in the periods, increasing the ionization energy. Next, coming to the electroaffinity. Electron affinity. Can anyone say what is electron affinity? Varsha Shibi, yes, good.
As the amount of energy released when an electron is added in the outermost shell of an isolated gas amount is known as electronic affinity.
Yes, sir. Electron affinity is nothing but in the ionization energy, removing one electron, but in the electron affinity, adding to the electron from the, adding to the electron, the outermost shell. The outermost shell or orbits is known as electron affinity, but that is in the isolated gaseous. When the isolated gaseous, then we can add the electron. Okay, so that is electron affinity. This electron affinity also, it is in the groups, it is top to bottom is decreasing. In the periods, it is increasing. Next, coming to the electron negativity. Electron negativity. The electronegativity is depending on the electronegativity also is depending on the ionization energy. Electronegativity is depending on electroaffinity and ionization energy. This ionization energy plus electroaffinity by 2 is known as a electronegativity. Electronegativity. Okay. Now coming to the electropositivity. Electropositivity. This electropositivity is opposite to the electronegativity. Opposite to the electronegativity. So, just wait a minute. Electronegativity is depending on ionization energy and electroaffinity by 2, then we will get that is a electronegativity. Electronegativity is quite opposite to the electropositivity. Electropositivity. So that's why electronegativity in the groups decreasing from the top to bottom, in the increasing in the periods. The electropositivity is in the groups, it is increasing top to bottom and decreasing in the left to right. Next, coming to the metallic nature. Just now we have discussed the metallic nature is less in the electronegativity. Less in the electronegativity. That's why in the groups it is increasing. In the periods it is decreasing. And non-metallic nature. In the non-metallic nature, more actually in this. More of electronegativity. The electronegativity is more in the non-metallic, non-metals. So that's why in the groups it is decreasing from the top to bottom. In the periods it is increasing in the left to right. left to right. If you take in the non-metals, third group elements. Third group elements. Third group elements. See here. In the third group elements. In the periods you can see Amma. In the periods sodium, magnesium, metals, aluminium, silicon, non-metals, phosphorus, aluminium, silicon, metalloids, phosphorus, sulfur, fluorine. These are the non-metals. And neon is a neutral. Argon is a neutral, noble gaseous. Okay. So in the periods sodium and magnesium, metals, and aluminium, silicon is a metalloids, phosphorus, sulfur, chlorine. Chlorine is a salt, argon is a neutral, and phosphorus and sulfur is a non-metal. Okay. So like that, actually in the non-metals, it is depending on a electron negativity. So that's why we will observe in the groups and periods. This is your activity, Amma. Yesterday I have given the homework, complete the CW. Today this is your activity. Complete your activity in the CW. Complete your activity in the CW. Do you have any doubts again? It's a very, very easy lesson and important lesson. Easy and important lesson, Amma. They will ask these all: valency, atomic radius, ionization energy, electron affinity, electronegativity, metallic, non-metallic properties, characters, metallic, non-metallic properties. In the groups, how it will change, and in the periods also, how it will change. That they will ask at the modern periodic table also. S block, which is belongs to the S block, P block, D block, and F block elements. Complete your CW and as well as complete your activity. Now in the next class, we will start the new lesson, that is a 9th. Do you have any doubts again? And I will give a lab activity. Lab activity is the 5th lesson. In the 5th lesson, finding the refractive index of a prism. This is your lab activity, Amma. Finding the refractive index of a prism. This is your lab activity. Already I have given to the boys section, but I did not give to the girls section. So you can complete in the PW lab activity. Finding the refractive index of a prism. 5th lesson. In the CW, you can write activity, complete your CW lesson 7 and activity. In the PW, you can write a lab activity from the 5th lesson. Okay, ma. Bye everyone. Have a nice day. Thank you everyone. Thank you all of us.